Equations can involve more than one variable, and sometimes we're going to be asked to solve for one of the variables. In these problems on the right, both y and x are in the equations, but the problems ask us to solve for y. So we're going to treat x just like as if it were a number, and we'll use the same exact steps that we had used previously for solving. Our goal, though, is to isolate y. So I'll divide on both sides and write the results. I see that negative 4 can be divided by negative 2. It would be a 2. But I have to bring the x down as well. And so that's going to be my final answer. It's done because the y is isolated. In this next problem, there's several things to move away from the y. Okay, I want to get the 5 out of there. Notice that 5x and 5 are not like terms, so they have to stay separate. I can't like add them together or anything. We have to each have their own space. Okay, now I want to divide by 5. But one thing about dividing by 5 here is that if I do it on one side and I do it to the entire side, then I need to divide the other side, not just one of the terms, but all of the terms. That makes things truly symmetrical and truly equal. But now I'd really like to reduce and simplify this. And so I've got y equals negative 5x plus 5 over 5. And it's good to point out that there's a difference between what I have here and this. If I had that on top, then it would be okay to just cancel the 5 here with the 5 above. But we have addition between our terms. And when that happens, you can't just cancel the 1 5 with the other. Here's why. We would be allowed to break that up into 2 fractions if we want. So simply canceling this 5 with that 5 would not be enough because, yeah, those would cancel. But the other negative 5x term still needs to be divided by 5. So we have to actually be able to cancel all the 5's in this situation. That'll bring us to our final answer, which is y equals x plus 1. Okay. On the next one, I'm going to try to get the 2 away from the y. And as you can see, it comes out to a similar situation. 2x minus 2 over 2 equals just y. Yeah. So now let's cancel the 2 with all the 2's. It'll be x minus 1 equals y. That's good. All right, there's a few more to try here. Let's see, we'll get 8y equals negative 4x plus 6. We got to keep the 6 and the 4x separate. We want to divide by 8. And this one's going to be a little trickier to work with. I may wish to break it up into 2 fractions. Maybe that would be best for this one. Because now if I want to reduce them, I can do it to each one individually. So negative 4 over 8 will become negative 1/2 x. 6 over 8 can reduce to 3/4 if you divide both the top and the bottom by 2. And that's our final answer right there. Okay. Here we get y equals negative 3x plus 10 over 5. The 5 can reduce with the 10, but it can't reduce with the 3. So all I can do is just maybe break it up into 2 parts, but that's all I can do. All right, here let's move the 2x away from the y. Now let's divide by a negative. Okay, we're going to want to simplify that. We'd rather have just 2/3. 2 negatives cancel out. Here, we don't like negatives in the denominator in math. It's not considered simplified. So we'll just make this a -1. Perfect. And okay, interesting. So this one has denominators. And I showed in a previous example how to clear the denominators by multiplying by the least common multiple of them. So I'm going to do that technique here. I'll multiply both the right and the left by a number of my choice. I'm going to pick 6 because that is the least common multiple between 3 and 2. Now over here we're going to get 4y, 15x, minus 21 equals 0. 6 times 0 is 0. And then we would just solve it. I'll move the 21 over. And I might as well move the 15x over as well. Okay, that's going to give us 4y equals negative 15x plus 21. Finally, divide by 4. But you got to do it to all terms. So we get y equals negative 15 fourths x plus 21 fourths.